Hello everyone, welcome to my channel Data Mine Square. Today we will discuss degree of freedom. What this concept really is, why do we need this concept? We will understand it in detail. Before moving forward, let's see what the definition is. Degree of freedom measure how many independent values are free to vary if some constraints are applied on the dataset. You might be getting a little confused right now. Hold on, we will see in and out. Imagine if you have a bag and I say in this bag there are 5 balls and the mean weight of balls is 5 kg. So if you take out all the balls out of this bag and if you sum their weight, you will get 25 kg because while calculating the mean, we take all the data points, we divide it by the number of data points and we get the mean. Here we have 5 balls and the mean is 5, so sum will be 25. Now, you started taking out the balls one by one and you don't know what the weight is. You took out the first ball and you saw this ball is of 4 kg. You took out the second ball, this ball is of 7 kg. Similarly, the third one, the fourth one. So after taking out the 4 balls, we have now 22 kg. And we know if we take out the fifth ball, the total weight should be 25 kg. Now these 4 ball can have any values, but the last fifth ball, its weight is dependent on the rest of the 4 balls because the total should be 25 kg. Therefore, this particular ball has to have 3 kg weight. Why did it happen? Because in this data set, we are estimating a parameter called sample mean, that is 5 kg. And whenever we estimate a parameter, we impose a rule on the data, we impose a constraint over the data, and the constraint over here is that the sum of the weights of all the balls should be 25 kg. And because of that, whenever we put constraint reduces the degree of freedom. We estimated mean here and we saw last deviation is no longer free and hence the degree of freedom dropped by 1. In this bag, degree of freedom was 5, but after estimating the mean, while estimating it, we consumed the information, we consumed the degree of freedom, so degree of freedom is 4. Let's move forward and see sample variance. Sample variance is also a statistic like sample mean. This measures how much the values in a sample deviate from their sample mean. So sample mean calculates the center point of the data and sample variance calculates the deviation of the data points from its center. The mathematical formula to calculate sample variance is we take the deviation of all the data points from its mean, then we square it up, then sum. After doing this, we divide it by n minus 1. So let's calculate the sample variance in this data set. First, we will take the deviation of all the 5 balls from its mean, that is minus 1, 7 minus 5, we have 2, 8 minus 5, 3, 3 minus 5, minus 2, and similarly minus 2. And we will take the square of all these deviations, that is 22. Then we will divide this 22 by n minus 1 because n is 5 here and n minus 1 is 4, so we get 5.5. Now you must be thinking why n minus 1? Because in calculating sample variance, we are using sample mean here and we just saw when we estimate sample mean, it reduces the degree of freedom by 1. That is why we are using n minus 1 and not using n. We will see how much degree of freedom sample variance consumes. Like we saw sample mean consumes 1 degree of freedom, how much sample variance will. So whenever we estimate a parameter, we impose a constraint. So in this case, the constraint will be the deviation from the mean of all the data points will be 0 if we sum them. So now calculates the deviation. So first ball, it is 5 minus 1, 4. 5 minus 2, or 7 minus 5 is plus 2. Then for the third ball, it's 8 minus 5 plus 3, 3 minus 5 minus 2. So cumulative deviation of these 4 balls is plus 2. Therefore, the deviation of the last ball would be enough to neutralize this deviation to get 0 over here. So this fifth ball's deviation is fixed. Therefore, here also, like in the case of sample mean, our degree of freedom was going down by 1, while estimating sample variance also, our degree of freedom drops by 1. Here I have mentioned the list of parameters which we often calculate in statistics, and while calculating that particular parameter, how much degree of freedom it consumes. Mean, it reduces the degree of freedom by 1. Similarly, variance 1. In simple regression, the equation is like y equals to mx plus c. So if you calculate the slope and the intercept, it consumes 2 degree of freedom of the data. That's why it's 2. Now we will see why do we need degree of freedom. Because when degree of freedom reduces, data's ability to represent the population reduces. For example, if the dataset is huge, if the population is huge, and we won't be able to take the value of all the data points to estimate or calculate statistic. So we at that time we take samples of that population, and that sample helps us to represent the behavior of that the bigger data set. Whenever the degree of freedom reduces, we adjust the variances, uncertainties, and test statistics with the remaining degree of freedom in a way that the particular sample will represent the data in a better way. That is why we used n-1, not n, in sample variance. I will show you why n-1 gives a better representation of the population than n. Let's see. Assume in India, the average weight of the people is 60 kg. So the population mean is 60 kg, or the true mean is 60 kg. Now, it's not possible to take all the people's weight and divide the number of people to get this 60. What we do is that we take sample of people or group of people, then we calculate the statistics of those sample, and then we arrive at the population mean or the true mean, because these samples will represent the true mean or the population mean. It's the representation of the population, not exactly the population mean. So let's move to the action. I will use this for particular formula, normal distribution, and this assumes that I have a normally distributed data. In that data, the mean is 60 and the standard deviation is 10. So the variance will be 100. And I will take 500 samples. In each sample, I will have 5 data points. So let's see how I will arrive at this. So this function will give me random values of that population which follows this rule. And the rule is that mean will be 60, standard deviation will be 10, and variance will be 100. So I take 5 values in sample 1. And similarly I will take 501 samples. So we have now 501 samples, and in each sample I have 5 values. If I calculate the mean here, average of this sample, that is sample mean, is 62. Now if I take the mean of all the 501 samples, the mean will be 60. You can see here. Now the point what I was telling you, why we use n-1 instead of n. First we will see what will happen if we will use n to calculate the population variance. So the variance we got for the sample 1 is 19, and if we take the variance of all the 501 sample, we will get 80. But we know that variance of our population is 100, not 80. Now let's see what will happen if we use n minus 1 instead of n to calculate the variance. And when we use n minus 1, we call it variance of sample. So we got 45. Now we will take the variance of all the 501 samples and we will get 101. So now you can see in this data I have 500 samples, 501 whatever, and if we are dividing it by n, we are getting 81 as variance, but the actual variance is 100. And when we are adjusting the variance with the degree of freedom and use n minus 1 instead of n, we are getting 101 as variance. That is very close to what actual population is. So whenever we calculate one particular statistic, that is sample variance, and that sample variance represents the population, and when the degree of freedom reduces, and if we don't adjust the statistic with the free available degree of freedom, that particular statistic will not be able to represent correctly the population. So that is why we need degree of freedom. Finally, whenever we estimate a parameter from data, we restrict data with a rule. Now, whenever we impose some rule on the data, its freedom will reduce and fewer independent pieces will be available there. And we will have to adjust the statistic with the available degree of freedom to represent the population in a better way. And more degree of freedom, it means more reliable estimation of the population is. I hope you like this video. Thank you so much. Do like, comment and subscribe. Thank you so much.